All right, picture this. It's the year 1877, and across the globe, millions of people are literally starving. In British India's Madras Presidency alone, the streets and villages are completely overwhelmed. It eventually leads to a staggering, heartbreaking loss of over 2 crore. That's 20 million lives. But the horror didn't actually stop there. China lost up to 3 crore people. Millions more perished in Brazil, Egypt, and South Africa. And over in the US, in Minnesota, it was eerily dubbed the year without a winter. Now, you'd probably assume this level of mass devastation was the result of a global war or maybe a catastrophic plague, right? Well, it wasn't. The root cause of this unimaginable tragedy was actually a sudden, silent atmospheric shift happening thousands of miles away, out in the ocean. So, welcome to this explainer. Today, we're breaking down the impending 2026 extreme weather forecast. And we aren't just looking at the future here, we're actively using powerful historical data to understand exactly what's coming our way. We're going to examine a weather cycle that historically wiped out millions and unpack the chilling mathematical and economic forecasts that scientists are predicting for the next decade. You might want to grab a notebook, because understanding this could seriously change how you prepare for what's next. Section 1. The Science of El Niño. A shift in the winds. Okay, to understand how weather can kill on such a massive scale, we have to look at what happens in the eastern and central parts of the Pacific Ocean. This is where a phenomenon, affectionately named El Niño, which is Spanish for little boy by 17th century Peruvian fishermen, actually originates. Under normal conditions, you have these strong trade winds blowing from east to west. Think of them like a giant fan, basically pushing warm surface water toward Asia and Australia, which then allows cold, deep water to rise up near South America. But during an El Niño, that giant fan just kind of loses its power. The trade winds weaken. Suddenly, trillions of liters of warm water just stay trapped in the east. The ocean surface heats up, releasing so much energy into the atmosphere that it completely rewires global wind and rainfall patterns. So places that desperately expect rain, like India and Australia, are suddenly plunged into severe drought. Now, the distinction between a regular everyday cycle and a highly deadly one comes down to a really tiny margin. El Niño is a natural cycle. You know, it usually happens every 2 to 7 years. But when ocean surface temperatures spike more than 2 degrees Celsius above average, it evolves into what we call a super El Niño. I know, a 2-degree difference sounds incredibly small, right? But spread across the vastness of the Pacific Ocean, it is an astronomical amount of heat. This exact phenomenon is what triggered those global famines back in 1877. And worryingly, European weather models indicate we're hurtling toward another one in 2026. Section 2. The 2026 super anomaly, the math of disaster. When you look closely at the math for the coming decade, it's honestly terrifying. 2.9 degrees Celsius. So before the Industrial Revolution, an El Niño would push temperatures up by maybe 1.4 or 1.5 degrees. But today, thanks to climate change, our planet's baseline temperature is already roughly 1.4 degrees hotter. So when this 2026 El Niño hits, it's expected to just add another 1.5 degrees right on top of that elevated baseline. The net result is a massive 2.9 degree anomaly. Human history has literally never recorded a temperature deviation this extreme. To put that into perspective, the source uses this perfect analogy. Imagine sitting in a room that is already 40 degrees Celsius and someone turns on a heater. That's exactly what rising global baseline temperatures are doing. They simply amplify the already dangerous effects of recurring natural weather cycles. The room we're all sitting in is already dangerously hot, and El Niño is the heater. Section 3. Agriculture and food inflation, the ground level impact. So what does a warmer ocean thousands of miles away actually mean for you and me going about our daily lives? Well, consider India's immense agricultural vulnerability. A staggering 51% of India's agriculture relies completely on the monsoon rains. Think about that, over half. There are no backup irrigation canals or deep wells for these farmers. They literally just look to the sky. And El Niño's primary effect on the subcontinent is suppressing those vital monsoon rains right when the crops need them the absolute most. This kicks off a very logical and frankly brutal cascading domino effect. Weather forecasting agencies are already predicting below normal monsoon rainfall, hitting around 92% of the average. Less rain directly means lower food production across the board. And when supply drops, the financial dominoes start falling fast. Prices skyrocket. Historical data shows that during an average El Niño year, global non-fuel prices jump by about 5%. But during a super El Niño, food inflation can aggressively spike all the way up to 9%. So that atmospheric anomaly out in the Pacific directly translates into crippling grocery bills and food insecurity for the average citizen back home. Section 4. Urban heat and the human cost. Now, looking at the Delhi 2024 temperature data, the true alarm bells don't actually ring during the day, they ring at night. The daytime temperatures rose by 1.8 degrees, which is bad, but nighttime temperatures spiked by a shocking 4.4 degrees. This is the deadly urban heat island effect in action. Our concrete buildings and paved roads absorb the sun's heat all day and then just radiate it out all night long. We naturally assume the midday sun is the biggest threat, but it's actually the nighttime heat that's often the most lethal. Because when the temperature doesn't drop at night, the human body never gets a chance to cool down and recover, which massively multiplies the risk of fatal heat strokes. And we really need to talk about the sheer inequality of this crisis. In India, around 38 crore, that's 380 million informal workers, from construction crews to street vendors, are highly exposed. They can't just step inside and turn on an AC. Studies show that just a 1-degree rise in temperature causes a 14% drop in their daily earnings, simply because they have to spend money on water, ice, and medicine, or they just physically can't work through the peak heat. On a macro scale, extreme heat cost the economy an estimated $194 billion in 2024 alone. Yet the source material highlights a critical policy contrast. India currently excludes heat waves from its official list of notified natural disasters. So unlike several European and neighboring Asian nations that immediately trigger federal emergency funds and work stoppage mandates during severe heat waves, India's lack of official recognition means authorities avoid the mandatory financial compensation of 4 lakh rupees per confirmed death. Because of this, the true human cost goes severely undercounted, leaving the most vulnerable totally unprotected.
Section 5. Adapting to a new normal, urban evolution.
Which brings us to a really vital question. What can one single person actually do against something as massive as a super El Niño? You can't stop the ocean from warming, and obviously you can't single-handedly reverse global climate change. It is so easy to feel helpless against the sheer scale of this. But the source data actually outlines several very practical, highly impactful ways we can adapt. Let's walk through these concrete actions. First up, and this is absolutely crucial, save old trees. Studies show that mature trees can cool the immediate pedestrian level by up to 12 degrees Celsius. 12 degrees! That is literally the difference between a pleasant afternoon and a lethal heat stroke. Second, carry oral rehydration salts, or ORS. It's incredibly cheap and it's your frontline defense against severe dehydration. Third, actively look out for those who can't protect themselves. Offer water and a bit of shade to delivery personnel and outdoor workers. And finally, transition to solar power where you can. Even war-torn countries like Syria have seen massive adaptations by using cheap solar panels to power homes. Cutting our reliance on the coal grid not only saves money, but directly reduces the emissions driving that baseline temperature up in the first place. But regarding those trees, we need a really sobering reality check here. Current urban planning is failing us. The data shows that between 2015 and 2019, for every 1 square kilometer of new trees planted, 18 square kilometers of old, mature trees were cut down for mining and infrastructure projects. And sadly, planting a tiny new sapling just doesn't magically replace a 100-year-old tree. Most new saplings die, and the ones that do survive take decades to provide that 12-degree cooling effect we desperately need right now. Saving existing mature trees is exponentially more effective than planting new ones. I want to conclude this explainer with a really powerful, provocative thought straight from the source. Children born in 2026 will never know what a normal 35 degrees Celsius summer feels like. That hits hard, doesn't it? Without immediate, aggressive adaptation, protecting our mature trees, shielding our vulnerable workers, and fundamentally shifting our energy grids, extreme, dangerous heat is just our permanent new baseline. El Niños are going to keep coming, and they're going to hit a hotter Earth every single time. So the big question is, will we evolve our cities and our habits fast enough to actually survive them? Think about that next time you step outside and maybe take a closer look at the trees in your own neighborhood. Thanks for joining me today, and keep questioning the world around you.